Good morning, Unit 10, Classwork 10. More on angle relationships in circles. So we're talking about angles here this week and for our quiz on Friday. Next week, we're going to talk about segment lengths. But for now, we're just in the realm of angles. So let's go to some prior knowledge. Find the measure of angle VUY and the measure of angle VUW. Make sure I got a good pen. The measure of angle VUY is 1/2. That's the 68 plus 94. So VUY is this angle and its vertical pair. 68 degrees plus 94 degrees. Put that in the magic calculator machine, and that angle is 81 degrees. And to find the measure of angle VUW, then that's these ones. Well, we can just use a linear pair. 180 degrees minus 81 degrees equals 99 degrees. So, let's wait. Hold on. I want to do this problem and then I'm going to talk about something else. All right. In each of the following, so notice the intersection in problem 1 is inside. So I'm going to write inside here. Here, the intersection of the two lines is outside. So for outside, we want to find x in each of the following. For A, this is that one circumstance where you've got two tangents. And so this arc here is 360 degrees minus the 116. And that equals 244 degrees. And so x equals 1/2 244 degrees minus 116 degrees. And so the measure of angle x is 64 degrees. That's that one special circumstance when you have two tangents. For B, you have a tangent and a secant. And so this, we don't know, but also we don't care. So angle x is 1/2 173 degrees minus 79 degrees, and x equals 47 degrees. So we have inside where you add the arcs and divide by 2. You have outside where you subtract so take the bigger arc or the arc further away and subtract the arc closer to the angle. And then, sorry, super slow drawing. You have on. And that's just your inscribed angle, half the measure of the arc. So inside, outside, and on the circle where lines can intersect. All right, we have one more angle relationship in circles. So if we draw a circle in one of its diameters, all right, let's do that. Here's a circle. And here's the center of the circle. And here's its diameter. And we can call the diameter AC. If we draw a tangent to the circle at A, so remember, tangent is a line that touches a circle in one place, but it's also perpendicular to the radii at the point of tangency. So if we draw a tangent to circle A, right there, sorry, that should be touching the circle only at one place. What type of angle is formed? So the measure of AC is 180 degrees. It's a straight line. Straight lines measure 180 degrees. The measure of angle A at the point of tangency is 90 degrees. And this arc, AC, also equals 180 degrees. What am I? 80. So it's that last point that we want to investigate today. Here we go. The last relationship for angles that we're going to study. If a secant and a tangent intersect at a point of tangency, then the measure of the angle formed is half the measure of the arc. So let's look at the diagram. AD is tangent at point B. The center is somewhere here. But that intercepted arc of the chord creates that arc BC. What we're saying then is that angle B, ABC, is going to be half arc BC. I'll give you a second to think about that. Which means then you've got two angles, and they should add up to 180 degrees, right? All right. So we want to find the measure of ABC, this one right here. We know that the little arc AB is 102 degrees. So the measure of this is 360 degrees minus 102 degrees. So the measure of ADC is 258 degrees, which means the measure of angle ABC must be half that. $129 degrees. So that's it. We are going to practice today's classwork and homework. To your relief, will be much less challenging than yesterday, day before's homework. So here we go. What do we have? We have intersection of two chords inside. Inside means we add. Notice where angle 1 is, however. So I'm going to put an X right here, because that X, we know, is half the sum of 38 and 46. So X degrees is 1/2 38 degrees plus 46 degrees. X is 42 degrees. And the measure of angle 1 is 180 minus 42. We're going to call that 138. Well, let's see, we need to find the measure of angle 2. Well, I see where the 100 is. This is 260 degrees. So the measure of angle 2 is half 260 degrees, or 130 degrees. That's our new theorem. For problem 2, we intersect outside the circle, so we know we're going to do some subtracting. What do I notice about this diagram? I notice that I have a diameter. So 180, subtract 52, subtract 84. You are always on the hunt for your semicircles. It's 44 degrees. Sorry, that doesn't look so good. 44 degrees. So x is 1/2 84 degrees minus 44 degrees. X is 20 degrees. Well, let's see. I have 3 arcs, or 2 out of 3 arcs for the circle. I can subtract 148 and 128 from 360. So that makes this arc 84 degrees. So x is half 128 minus 84. X is 22 degrees. And the next one, well, I've got x, and I know this arc here is 360 minus x. So 55 equals 1/2. I'm going to do big brackets. X minus 360 minus x. Okay, I might have gotten carried away with this bracket here. All right, I'm going to multiply both sides by 2 to get rid of that 1/2. So I have 110 equals, when I distribute my negative, I'm going to have negative 360, and I'm going to have plus 2x. Add 360 to both sides. I'm going to get 470, divide by 2. I'm going to get x equals 235 degrees. Let's practice a few more so you see all the different varieties. I know in 3a that 3a plus 6a plus 4a plus 5a, all those added together will equal 360. So 3, 6, that's 12, 13, 14, 15, 16 plus 5. Wait, come on. 3, 9, 10, 11, 12, 13, 18. 18a equals 180, which means a equals 10, which means you have 50 here, and you have what am I doing? See, somebody's going to email me right away and go, you're doing it wrong. 18 A equals, see, I haven't finished my coffee, that's why. 360 degrees, not 180. Common mistake. A equals 20 degrees. Over here, 5 times 20 is 100. 6 times 20 is 120. We've got angle 6 equals 1/2 120 plus 100. Angle 6 is 110. All right, it looks like we have that new theorem where we have a tangent and we have a secant. So angle 7 is just going to be half of 196. Angle 7 equals 98 degrees. And look at that, angle 8. When you have a diameter to a tangent, angle 8 equals 90 degrees. 120 over, so for problem D, 120 for one arc, 240 for the other arc, half of 240, angle 9 is 120 degrees. And we want to know angle 10. So we've got 100 plus 160, that's 260, which makes the arc here 100 degrees. 1, 2, 360, which means that angle 10 is 50 degrees. And then we want to know the measure of AC, intersecting inside, so we're adding, and I'm going to do this. 65 degrees equals 1/2 AC plus 72. Multiply both sides by 2, subtract 72, and we know that AC is 58 degrees. Thanks for bearing with me with all my video mistakes. You all have a wonderful day.